Welcome back, students. This is the session 27 from JEE Physics. The chapter is current electricity, and I have written a question here for this session. The question here is the VI graph of a conductor at temperature T1 and T2 uh, are as shown in this figure. The term T2 minus T1 is proportional to. So these are the four alternatives which we have been given, and we have to find the correct one. So now here this is the origin, and this is the x-axis, and this is the y-axis. So the current is represented on the x-axis and the voltage on the y-axis. Now this is a line here which now this line is basically what? This line is giving us the value of resistance of this conductor at temperature T1 and at temperature T2. Let us take at you can just take one point here. I'm just drawing here one line. Let us say this is the point A, this is the point B, and this is the point C. So from this graph, we can clearly see that tan theta is equal to BC upon OC. Okay, so and this is theta. So this angle is what? This is equal to, this will be equal to 90 minus theta. So we can also write that tan 90 minus theta will be equal to AC upon OC. Okay, now tan theta is equal to BC for this line, or tan theta is equal to BC upon OC. Now this is basically what? BC is what? So at any moment of time, this BC will give you the voltage. This is the value of V, and OC is what? It is the current. So at temperature T1, the value of tan theta is equal to V upon I, where V is the voltage at any moment of time and T is the current at any moment of time. And the ratio of V upon I is basically what? It is the resistance of that conductor at what? At temperature. This is the resistance of this conductor at temperature T1. Let us say this resistance is R1. So what is R1? R1 is basically the resistance of this conductor at temperature T1, and it is represented by or given by tan theta. Similarly, tan 90 minus theta is equal to AC, and this is again what it will be equal to the resistance of the conductor at temperature T2, say it is R2, and this will be what? That is tan 90 minus theta will be equal to cot theta. So here I will be writing here that tan theta is equal to R1, which is the resistance of the conductor at temperature T1, and cot theta is equal to R2, which is the resistance of this conductor at temperature T2. Okay. So now we also know that the resistance of a conductor is also given by RT is equal to R naught 1 plus alpha T, where RT is the resistance of the conductor at the temperature T. R naught is the resistance of that conductor at 0 degree centigrade, alpha is the temperature coefficient, and T is the temperature. So using this relation, I will be getting two equations now. Considering the this line which is inclined with the x-axis at an angle theta. So R1 will be equal to, where R1 is what? It is the resistance of that conductor at temperature T1, is equal to R0 1 plus alpha T1, and similarly R2 will be equal to R0 1 plus alpha T2. Now R1 is what? R1 is equal to tan theta. So it implies that tan theta is equal to R0 1 plus alpha T1, and cot theta is equal to R0 1 plus alpha T2. So these are the two equations which I have got, and now we will simplify these two equations to get the final answer. That is, we have to find the value of the term T2 minus T1, and finally we have to find that T2 minus T1 is proportional to what? That is, whether it is proportional to sin 2 theta, cos 2 theta, cot 2 theta, or tan 2 theta. So now from this these two equations, I can write down cot theta minus tan theta will be equal to R naught plus R naught alpha T2 minus R naught minus R naught alpha T1. That is, cot theta minus tan theta will be equal to R naught plus R naught alpha T2 minus R naught minus R naught alpha T1. So this will get cancelled out. So it implies that cot theta minus tan theta will be equal to R naught alpha T2 minus T1. Now we are supposed to find the value of T2 minus T1, and finally we will be able to find that T2 minus T1 is proportional to what? So T2 minus T1 is equal to T2 minus T1 will be equal to 1 divided by R naught alpha cot theta minus tan theta. Now cot is equal to tan is equal to sin upon cos, and this is equal to cos upon sin. So cos theta upon sin theta minus sin theta upon cos theta. So it implies that T2 minus T1 will be equal to 1 R naught alpha 1 divided by R naught alpha, and this will be equal to cos square theta minus sin square theta. So cos square theta minus sin square theta divided by sin theta cos theta. Sin theta cos theta. So T2 minus T1 is equal to 1 divided by R naught alpha in bracket. Now cos square theta minus sin square theta is equal to cos 2 theta. And if I multiply this, see, this is sin theta cos theta. Now 2, if I am just multiplying it by 2, and if I am multiplying this by 2, I will be putting here 2, so that the equation remains the same. So what I have done is, what I am doing here is, this is 1. So here I am just multiplying and dividing this equation by 2. So I will be multiplying and dividing this equation by 2. So I will be getting this equation. That is 2 R naught alpha in bracket cos 2 theta divided by 2 sin theta cos theta. So this equation and this equation is the same. What here I have done is that I have multiplied this equation, multiplied and divided. I have multiplied and divided this equation by 2. So it implies that now this is equal to 2 divided by r naught alpha, and this is equal to cos 2 theta divided by sin 2 theta, because 2 sin theta cos theta is equal to sin 2 theta. So I have substituted this the value of this 2 sin theta cos theta by sin 2 theta. Similarly, this cos square theta minus sin square theta is equal to cos 2 theta. Okay, so that so what I have done is I have substituted the value of cos square theta minus sin square theta as cos 2 theta. So finally what I am getting is 2 divided by r naught alpha into this is equal to cot 2 theta. So T2 minus T1 is equal to 2 divided by r naught alpha into cot 2 theta. Now this is a constant, 2 divided by r naught alpha. Alpha is the temperature coefficient, so this is a constant value for this conductor. R naught is the resistance of this conductor at 0 degree centigrade, so that is again a constant. So if I remove this constant, we can say that T2 minus T1 is proportional to cot 2 theta. So our correct option is B. Okay, so this is how this question needs to be done. So this was a good question, and that is the reason why I have taken this question for this session. And in the next session, I will be continuing with the same chapter, that is current electricity. And I will be taking up another question which was asked in the JEE means examination in the next session. So till then, have a nice day. Bye.